Hello and welcome back. Big things happening in this video. So today what I'm going to do is I'm going to create shader objects. Now the whole pipeline thing sort of has a checkered past with Vulkan. The idea is that back in the day we were coming to a sort of combinatorial explosion of very dynamic state in renderers. We'd have Unreal Engine, still generating hundreds of thousands of shaders, seemingly for no discernible purpose. But anyway, there was an idea that if things were made more or less dynamic, that overhead would decrease, performance would increase, and the benefits of that would be so convincing that everything would change. Spoiler alert, everything did not change. It just made Vulkan really hard to work with. And so a number of the recent improvements in Vulkan have been basically making it more like OpenGL was before, so in the past we would have to create a pipeline explicitly, and that pipeline would include all the information and all the configuration for every single stage. And if any of those things changed, we would have to then create a new pipeline. So you could have a shader, and then if you want that shader to output to an image of a different size, well, now you have to recreate the pipeline. We're not going to do that. A shader object is a more dynamic object. It's still pre-validated, but it just doesn't have as many restrictions. So I guess I should talk a little bit about sort of the background work that I'm doing for this. So there are a few things. First up, if we look on the side, we've got this shaders file. Inside this shader file, I've got like some GLSL files, but they need to be named appropriately. So my fragment shader needs to have the frag file extension, and my vertex shader needs to have the vert file extension. But I'm not actually going to go into a lot of detail on these shaders. They're pretty standard. I might look a bit more at them in the future. But what's happened is we start with this GLSL code, and then we compile that code into SpearV code, which is an intermediate. Whoa, that was loud. It's an intermediate bytecode, which is okay. Fair enough. What's Google doing? Oh my goodness, Google, get out of my shader code. Oh, that's scary. Okay. There we have it. I'm just going to be using these files because the focus of today's video is not going to be on like what is GLSL. The focus of it is going to be on how do we use this to make shader objects. One thing we're going to need is we're going to need to read files. So I've gone ahead and made this file loader. What it does is it basically just opens up a file, grabs the whole contents, basically mem copies it onto a buffer, which is, an array of bytes, and then returns that. It's just the simplest way of dumping files into memory. Okay, cool. So with that out of the way, I'm going to have a look at my shader stuff. So in my shader header, again, I'm going to take in a bit. I need to update this. I'll do that later. Okay. That's code for I won't do it. But anyway, so we take in a logical device because that logical device is going to need to do some creation. We're going to take in file names for both the vertex and fragment shaders because we could create these things completely independent of each other. We don't need to link them. But given that I know my problem, given that I know that I'm going to have a vertex shader and a fragment shader, and they're going to go together, it's probably beneficial to create and link them at the same stage. Now this dispatch loader dynamic, if you remember back to my debug messenger, we had one of those. I'll talk a little bit about this at a later point. And then of course, everything we create we need to destroy. And these things are created by the logical device, so they're going to be destroyed by the logical device. So we're going to take that deletion queue in as well. Let's pop over to the source file and do some work. As you can see up above, we've got this shader create info struct. I'm going to need to make 2 of these. Okay, so to start with flabs, what's with that? It's been a while since I used this keyboard. Anyway, to start with, I'm going to use the link stage flag, and what that will do is we're going to create both these shaders at the same time. So we're going to pass in an array of 2 create infos. Because both of those create infos have got the link stage flag set, then when we compile them both at the same time, they will also be linked together. And then we know that the vertex shader is going to have a fragment stage coming after it, so we can declare that up front. Then we can go ahead and we can load in the code for the vertex. Okay, we've got 2 options here, either binary or spear V. We're going to use spear V. Binary is if you want to go really ham and make your own like custom binary format. We're not going to do that. And then this p name is the name of the main entry point. It's going to be the same for both the vertex and fragment. So pretty much we're just going through and we're setting items. When it comes time to set the stuff for the fragment shader, some things are going to change, some things are going to stay the same. Just a little note, there is some stuff that we have not touched at all. We've got set layouts up above. Whoops. Push constant ranges and specialization info. So I can give a brief description of some of these things. Specialization info is the idea that our shader may have some constant values, for instance, and we may know ahead of time what those constant values are going to be. So we can actually provide a mapping for those constant values to substitute that in. Push constants are a way of getting resources really quickly to a rendering operation. And the shortest description I can come up with is that we have these things called command buffers which record drawing commands, because a drawing command is basically isomorphic to a bunch of numbers, being the parameters. You have one number, which is a type of function, another number, another number. Why can I not speak? All the parameters, which means that these command buffers where the things are recorded are very lightweight. They can't fit a lot. And that means that the resources that we bind generally have to be external to the command buffers. They have to have their own lifetime, and they have to be not on the command buffer. But for things like matrices, they don't take heaps of memory, and so you can record them directly onto a command buffer. This gives the benefit that A, it's really quick to update a small resource on the command buffer, and B, that update appears synchronous. If we write a push constant a number of times over the course of rendering, it maintains that ordering, which doesn't happen with large resources. And then this set layouts is basically really large resources. So if we have really big external buffers that we want to bind, we declare up front that they're going to be bound. But because we're not doing any of that, we just haven't touched it at all. Okay, so the next thing I'm going to need to do is exactly the same, but with the fragment shader. And we don't need to change the code type. It'll be the same. And same with the main. Okay, flags are going to stay the same. Next stage. So next stage is actually optional. Oh, sorry, this stage. What am I thinking? No, this stage is not really optional. Maybe it is. I don't know. Haven't tried. But next stage is optional. So the fragment shader does not have a next stage. Next stage, it's done. Code type. Yeah, that's fine. Code size. Yeah, I think that should all be fine. Let's find out. All right, so what we've done is we have basically got two create infos that we've set up. So I'm going to bundle them together. Give it a starting size. And there we go. And now what I'm going to need to do is I'm going to need to pass all this stuff over to the creation function. So here's how I'm going to do that. I have the standard pattern, go logical device, create shaders extended, and I'm going to need to put a few things in here. So the first thing I'm going to need is this sort of create infos, and I can just pass in a vector for that. Shader info, that's fine. The next thing I'm going to need is my allocator, and I am going to put in explicitly null pointer for this, and I'll show you why in a second, is because I want to put in something for my dispatcher. So typically the dispatcher is, it says here, get dispatch loader static. However, the issue with this is that the static dispatch loader doesn't know about the instance or the logical device or any of that stuff. And that's a problem because this is an extension. It's loaded externally. It's not a part of core Vulkan, which means that if we go and we just leave the default value here, it'll go fine. It can compile, but then it will say, hey, you know, we looked under the hood at the static dispatch loader and we just couldn't find that thing. So what I'll do is I'll just pass in the dynamic loader from the parameters. But again, if you don't remember exactly how we got this, we can, in the Vulkan HPP, create dynamic loader objects. So if we go up to the constructor, we went ahead, we made the instance, and then we said, all right, let's create this dynamic dispatch loader instance object. And this is basically, think of it like a really big wrapper around what you would do in the C API. You would call get instance procedure address, based on that instance, querying the specific name. Then you would do a reinterpret cast. You'd cast that back into a pointer function, and then you'd call that. And what this dynamic loader is doing under the hood is basically the same thing, but by associating an instance with this, we are sort of wrapping it up in a better interface. Anyway, so long story short, can you tell that I spent hours trying to debug this? Anyway, we got it working. Cool. So what I'm going to need now is I'm going to need a result. So I'll make a vector of the actual shader objects. And now I will do some stuff. Okay, so just like in the last video, because I'm handling sort of vectors of results, I want to make sure that those things can be copy constructed, so I'm taking the 64-bit handle to those things. But otherwise, I'm pretty much doing the same thing as I was before. And what I'll do is I will go ahead and put on the destructor function for the fragment shader as well. But yeah, so far so good. So I'll just step through this again because why not? So what we want to do is we want to go ahead and create a bunch of shaders from some source files. We can sort of pop over and see how this is being done. We go, hey, I'm going to make some shader objects based on this info. Okay, so then we go through and we describe the shader objects. And then we take those descriptions, we bundle them together in one call to create them, create and link them together. Then we check, we put on the deletion functions ready to go, and then we're done. So let's give this a go. I know what you're saying. You're saying it's not going to work. We're going to get validation errors. Yeah, we totally are. Maybe I wasn't expecting that error. Okay, so just off the top of my head, I think that perhaps one of the reasons I'm getting this strange error that doesn't make sense to me is that I have not enabled the extension. So if I go back and I look here at all the stuff I was printing out before, I can see that I think it's the device, right? Because the device creates these shader things in the first place. So if I go physical device extensions, it's Vulkan extension. Here we go. Vulkan extension shader object. So I'm going to grab that, copy that, and then I'll go over to the device creation. Here we go. Extensions down here, swap chain, and I'm also going to, and side note, I realize that this is like a slight memory leak. I'm going to have to fix this. It's not massive, but I will fix it. Just want to have time. Enabled. There we go. Okay, cool. So let's give that a go. Okay, cool. So see, now it's worked, but we've also got this validation error. Let's go ahead, close it, and check, see if it still works. Okay. So it looks like both of the validation errors that we got are in the same vein. It's basically saying, all right, you're trying to create or destroy shader objects, but you haven't enabled the shader object feature. Now this might be a little strange because we totally did enable the shader object extension, but we just didn't. I know, it's weird. So here's what we do. We've got the shader extension. We go up, we've got this device features. And I look this up, and this is like one way which was, they said you could do it. I'm going to go ahead and do it that way. So go physical device shader object features. It's not a short word. And it says here, what we can do is we can put in, where are we? Yeah, we put in a few things. We put in basically a bool or an integer indicating whether to enable this thing or not. And then we've got an optional next pointer, which could point to another feature that we want to enable. But I'm just going to say, yep, enable it. This is chaotic neutral enabling, as they call it. And then what I'm going to do is I'm going to pass this in to the device stuff. So I've got this device creation info struct that I've filled in. I'm just going to put this in as the the next pointer. And there are slightly more elegant ways of doing this, but I'll just do this. There we go. All right, so give it a go. And now I can see that we've got this. It says we've successfully made the shaders. We're not getting any validation errors, which is awesome. And in fact, we can close it down. Please, please, please. Awesome. And we're closing it down with no validation errors. So I think one thing I've learnt with Vulkan is you have to be really, really like walking on eggshells, because it's easier to fix a mistake early than it is to try to after the fact. It's not fun. Anyway, so that's it for today. I hope you had fun, and I look forward to seeing you again soon. Have a good one. Bye.